So the Lookback node has two purposes here. I'd say if you've ever watched any of the BloodHound workshop videos here, definitely from time to time, this Lookback node gets used a lot for its displacement function here. So what that does, so I'm going to use this stochastics solver here. Actually, this is a threshold solver here. So let's look at it here. Right. And let's delete that there. Right. So essentially, this stochastics solver here, threshold solver, right, it's generating a long signal when the stochastics is overbought. And let's see, it generates a short signal here when, oh, hold on, let me straighten this back out. There we go. And there we go. All right, let's go back here. Yeah. So there we go. So when the stochastics is oversold, it generates a short signal. And I actually have these rectangles here on the chart, right? Highlighting or denoting, when exactly these signals occur. So this is will show exactly what the displacement does here. Let's connect that in and go like that. You can see now all the signals have been shifted forward or displaced forward by 1 bar, right? And if you've ever noticed when you go into the indicators window here, every indicator has this displacement function or displacement setting added to it. Right, so this displacement is actually a NinjaTrader function here, right? And all it does, right, is it shifts your indicator forward in time. Right, so if I took this SMA here and there, right, so we can see the SMA stops here. Now, if I displace it here, I'll displace it by 2 bars to over exaggerate here. Hit apply and bingo. Now you can see, right, the SMA is now plotting 2 bars ahead of where it normally plots, right? So so it's shifting things forward in time. There. You can also do a negative displacement now as well. There. So, right, so essentially that's NinjaTrader's displacement function here. So when we go back to BloodHound, let me go back to those signals. Here we go. Right, so we can see, right, that displacement function in the Lookback node is just doing the same thing, right? It's taking your signals or your output and shifting them forward. So the primary use case, I'd say, for this displacement is when you're trying to line up multiple indicators all together, right? So, it's pretty common for some indicators to react a lot faster than other indicators, right? So you might need to take your slower indicators and displace them forward in time so that the slower indicators can catch up, right? So I'll just kind of create a imaginary example here. I'll just grab one of these other nodes here, right? So let's say, this solver here, runs a little faster there than the stochastics. So you can probably take, this indicator, plug it into an AND node, but then your stochastics might need the assistance of a displacement to, the stochastic runs faster. And so because the stochastics will signal faster, you'll need to take that and push it forward in time so that the slower indicators have time to catch up, right? And then connect that together, right? So your faster indicators might benefit from the help of displacing them forward in time, so that the slower indicators can catch up there, right? Yeah. And let's see here. Yeah, so that's simply the displacement. Now, the look back node here is a way to require a certain minimum or maximum kind of number of signals there. So I think the most common one here is max. So I need to turn off the displacement for this. Actually, I'm sorry. Let's do the minimum first here. So so the minimum, right, is saying that we need a minimum of 3 signals to occur. So it's waiting for a minimum of 3 signals. So again, let's look at our signals here, right? So again, so our rectangles here are highlighting, all the bars where there's signals. And so with the look back node set to 3 minimum here, we only get an output when there is a minimum of 3 bars with signals, right? So we can see the first 2 bars, right, don't have a signal. And then once we get to the 3rd bar, then we get a signal here. Yeah, so this is kind of a simple way of saying, hey, I need X number of signals coming in before before you consider it, something actionable, right? So whatever it is, 3 or 4 or 5, right? So if I increase this to 5, there we go. So we now have, so the first 4 signals that come in right here, so bar 1, bar 2, bar 3, bar 4, and then when we get to the 5th one, then we actually have an actionable signal, right? So yeah, so using the mode minimum as a way of requiring a minimum number of signals coming in here. Now the opposite, max, functions a lot like the signal extender. Actually, that's basically what it is doing. Is in the signal extender here. Right, here we go, the signal extender. Right, so as the name implies, right, it'll take a signal and then extend it X number of bars forward in time. And this is kind of a quick and dirty version of the signal extender here, right? So the signal extender is more complex because you can reset the extended signals, right? You have these reset functions here to turn the signal extender off, right? So so the look back node, does not replace the signal extender because it doesn't have any reset capabilities here, right? But as we can see, if I set this to 5 and max, right, it takes our signals and is extending them forward, right, 4 extra bars here. So 1, 2, 3, 4. So remember, the signal itself is number 1. So so setting it to 5, we now have 4 more bars of signals being extended forward in time there. Now, the average is for fuzzy logic users. So I don't think anybody's going to use average, but as we can see, the output here now is averaging out the values coming in. So this, let's go. So let's take a look, right? So we have a look back period of 5. We're setting it to average, right? So we need 5 bars, and let's go forward here, right? So when we get to our 5th bar, we have an output of 1, right? But the first bar since there's only one signal, right, the average equals 0.2, 20%, right, or 0.2. So, right, once we get 2 bars with signals, right, so 2 out of 5, right, so 2 out of our 5 means, right, the output value, the average is 0.4, right, so on and so forth there. So once we get to 3 bars with signals, then our average, 3 out of 5, the average is 0.6, right? And then once we get to 5 bars with signals, right? So 5 out of 5 is 100%, or a value of 1. So the average, just a simple mathematical average calculation there. And again, only fuzzy logic users would be using the average. I think the majority of time, the minimum function here is what's going to be utilized. Yeah, so again, going back to the minimum mode here, right? So we need at least 5 bars minimum with signals before we get an output. There we have it. The lookback node is is a very simple function node here. So and I think it's fair to say that it's pretty rare that the displacement and the lookback node are used at the same time. Right, of course it can. So if I do use the displacement, right, we can see now the signals are pushed forward in time. If I turn it off, like so, right, our signals only exist on the bars that the signals come in, right? So again, right, our rectangle here is just to show us which bars have those signals. All right, that should do it for the lookback node.